if you can pop to the next slide, Aaron, what we've got on there is a link to a webinar that we've done previously. It's an introduction to our game server hosting, which was formerly known as Multiplay, and our Matchmaker products. So please scan it now. Don't watch it now. We've got some great content coming up for you, but if you take that down and watch that at a later date. We'll give it one more minute and then we'll kick things off. Still climbing up. Almost over the 300 of you joining us today, which is brilliant. Okay, let's get things started. My name is Matt Woods. I'm the Senior Product Marketing Manager for our multiplayer solutions here at Unity. I'll be your host for the webinar today. A couple of bits of housekeeping before we start. We're recording the session today, and we'll share that with you all afterwards. We've got a panel of experts behind the scenes as well, so we'll take your questions throughout, and then we'll leave for around sort of 20 minutes at the end of the session to have some live Q&As as well. In order to help us with those, please use the Q&A function in Zoom to ask your questions rather than the general chat. So we can collate them, any that are similar, and it's just much easier to track those questions in the Q&A rather than the general chat. That would be excellent. But you haven't joined to listen to me today. So I'm joined by our presenter, Aaron Moon. He's a senior partner engineer on our multiplayer team here at Unity. Aaron's been in the business of hosting for over 20 years, had roles ranging from developer all the way up to CEO, running his own company, and worked for many other hosting companies along the way. He's been in gaming for the last 4 years at Unity, working with hundreds of studios on their multiplayer game launches and beyond. So there's really not many people better qualified to take us through a webinar on mastering your multiplayer game launch. So with that, Aaron, over to you.
Awesome. Thank you very much for that intro. Just the first few things we're going to talk about here is that, we're going to kind of keep things simple. We're not going to go super deep dive on a lot of these things. Over the hundreds of games that we've touched and worked on over my time here, we've seen some things that might surprise you, and they're not all that difficult to solve for. So as we dig through this, keep some questions in mind, use the Q&A. We're definitely going to get to every question that we possibly can. But to start off, we're going to dig through designing game architecture with scaling in mind. We find that that's kind of a hitching point sometimes for studios. Game loop design, and we're not going to talk about code. We're not going to get into exactly how you should be building your game, but we're going to talk about just the frameworks, right? That keep in mind while you're considering multiplayer. And then backend. Obviously, games backends are difficult to design. They're all unique. And we've seen some things here we think are interesting that you might actually gain some learnings from. So first things first, we're going to talk about architecture. And the way we're going to talk about it is really just in the mode of client, game server runtimes, netcode, matchmakers, just the simple things. So a lot of times game studios, they don't really think of efficiency right off the bat. They think about metrics, they think about logging, they think about telemetry. They want to pack as many features in there as possible. They're really focused on monetizing early on, which is great. But a lot of times you're doing that too soon. And so what we've actually seen is what lands better is to kind of get rid of that bloat, right? Start with a minimum viable product as early as possible. Get that server time running, get that client working, get your netcode and your matchmaker locked in, and then just kind of build in from there. Sometimes you'll actually see studios that'll pack all these things in there just to find out that they've landed with a provider who might be able to provide a lot of the debugging or telemetry and metrics And so putting all of that in their game server runtime actually reduces ROI and increases that total cost of ownership. So keeping in mind a single executable is also something you want to focus on, and we'll go into that a little bit more as we move forward through the presentation. Locking in hosting providers, that's definitely something you should probably try to do early on. Again, understanding what they bring to the table that you might not have to develop for might save you a lot of time in the long run. So when we talk about simplifying your game design, what does simple look like? I've seen dozens and dozens and dozens of game server binaries and deployments. And in some situations, like we've represented here, we have a very complex design. Right? We've got not just a game server instance with little processes here, but maybe it spins up a whole bunch of ancillary processes on the same machine, matchmakers, logging, metrics, a whole bunch of different executables. So the complexity of this at scale really doesn't become apparent until you start getting into scale testing and you start realizing that maybe these things don't play very well together when you're piling in thousands and thousands of users. Ancillary services, might not have any resource fencing. So these things might actually start cannibalizing resources on the machine and impacting player performance. And so we've seen things like that. For us, if you were to lose, let's say, a launcher in this design, and we've seen this before, what happens to all of these other game server instances? What happens to all these other processes? Is there a single point of failure here? So keeping things simple really kind of eliminates a lot of these types of risks. Now, what does simple look like? If we were really just to consider that, it's trying to pack that single server instance. And if it has sub processes, just making that game server the parent process. So many orchestration platforms out there actually take that game server runtime and they manage that process. They watch it for resources, they watch it for logs, and they manage those individually. So if you've got something that's piling a whole bunch of game servers into one machine and it's managing all of those sub processes, you might actually blind yourself a little bit. So just a single executable, a matchmaker that's resilient, something that's maybe outside resilient on a backend service plane rather than hosting it on a machine is really the answer here. And so when we lose one of these, then it really doesn't take the other players with it, right? The blast radius is small. And so at scale, if you have a game server that misbehaves, it's not going to be the end of the world. Process forking is something that we don't find out about until somebody gives us a game server binary and we start evaluating it. And when we evaluate it, we see all kinds of different design considerations. So if you can get away with it, you definitely don't want a whole bunch of these types of ancillary processes on the same machine. Spinning up watchers and debugging, things like that might be redundant, but it might be better to do those as a sub process of the game server runtime because, if you've got a situation where that game server dies, and I have a whole bunch of cloud machines that this thing might be scaled into, I'm leaving all these processes kind of zombied. Now they're still eating up resources. They're still costing me lots and lots and lots of money. And I have no way to understand how to kill those things off. If I've got hundreds of cloud machines and, I'm already scaling into the hundreds of thousands of CCU, this right here is a huge, huge cost risk. So this type of thing right here, we kind of frown upon. If you can get away with it, just try to keep it as a sub process of your runtime. And the way that looks is just like we had simplified before, just something simple. If we lose the game server, it takes the child processes with it. It's cleaned up. We kind of call these cattle, not pets. So, if they die off, we can spin up another one relatively painlessly when we're talking about session-based games. And so just focusing on trying to keep it that simple will definitely eliminate a lot of problems, both at scale, development, and even when you're updating. And we'll talk a little bit more about updating in just a little bit. So as we move forward here, we want to talk about what we mean by conscious game loop design. So when I'm talking game loop, I'm thinking, how does your game loop interact with your infrastructure? How does your infrastructure support your game loop? Do you have lobbies? Do you have matchmakers? Do you have a reason to match in and out of lobbies and in and out of sessions from those lobbies? So keeping that in mind and how that lays across the infrastructure from the beginning is definitely a good idea. There's some pitfalls there. So, keeping in mind what kind of session design you've got. Are you building a persistent game like an MMO? Are you doing something that's extremely short sessions where you're actually in between each match, you're restarting those sessions and those run times reboot every single time a new match starts. Or is it maybe a long running session where you've got, a cleanup process after the last match and then a new session drops in? There's lots of gotchas here. So, long running sessions, we see a lot of problems. There's memory leaks, especially in like persistent ones. You might see there's a continually escalating usage of RAM, and it doesn't become apparent until maybe hours later. So those types of things are definitely what you'll see at scale. Testing early is definitely important there. Also, what you might not consider is that the IP of that instance, right? That server is not changing. So you have some bad actors out there who decide they want to figure out what the IP address of your game server is. Now it becomes a DDoS target. Maybe for whatever reason, it's competitive and their competitive advantage is to DOS a whole bunch of the competitors on that server. And, their experience is better than yours. And so they're able to win. So DDoS targets are definitely likely in longer running sessions. Cloud costs tend to be higher because it's always running, right? Even if there's no players on it. So keeping that in mind, maybe you need to lean more heavily on bare metal infrastructure rather than cloud if you're going to be doing this. And then patching. Patching is a pain when you're looking at long running sessions because, each one of these might have matches on it. You have to kind of kill off. Maybe your backend only supports one version of the game, and we'll kind of talk about that a little bit more. But yeah, long running sessions can be, a good and a bad thing, but there's lots of things to keep in mind. Extremely short sessions. We see this a lot, right? Think of a 2-player game. You've got maybe a couple minutes in that session. It doesn't sound like it's a real big deal, right? When you say my game is small and it's really tiny. Well, when you've got 500,000 of those, and those game sessions only last 2 minutes and they're only 2 players, that's 250,000 API calls to some backend infrastructure somewhere. So at scale, that backend load can be huge. And if they all, rage quit, or if you've got a situation with your backend where people get disconnected and they're all smashing that reconnect button at the same time, that backend load might be amplified many times. So we'll talk about resiliency in a little bit. Now, we also understand that short sessions are extremely hard on infrastructure. When you're restarting in between sessions and you're in cloud, you might have that CPU and that RAM spike at the very beginning of loading your process. That represents consumption in cloud. So that could be expensive. So definitely want to keep in mind how you handle that. Matchmaker needs, again, more robust. How many matchmaking tickets per player, right? How many can be generated? What happens if they get disconnected and they generate a new ticket? All of those things in short sessions are very complex, and some of them are pretty hard to solve for. So keeping that in mind, definitely at scale is something we've seen people misstep in. QoS, I think this is important because the internet is not reliable, right? You could have a server that's literally 30, 40 miles from you, and the ping time on that is 10 times worse than one that's 500 miles from you. And that's typical. The internet is a weird place. So when we talk about QoS, you want the ability to have a provider that can give you services that will let you real time send your game client a list of IPs so that they can ping what that server region should be based on real telemetry and real data rather than just, physical location. Metrics and telemetry are exceptionally important in short sessions. If I have a short session game and I'm playing it, something goes wrong, I'm just going to quit, right? I'm going to go start another one. I'm not going to take the time to complain about it or let an admin know or engage your live ops team to let them know, hey, this crashed because of these things. I mean, if I really have the time and I'm a good person, I might be able to do that. But at large, your players are just going to start a new game and they're not going to think about it. So if you're not drawing metrics and telemetry out of every one of those short sessions, you might miss things that are actually going wrong in the game. Now, when we talk about persistent sessions, this is way different, right? We're talking world servers, MMOs. You're doing a player migration from this server to another one. As you step through a portal, that's what's happening, right? So you're actually physically moving to another machine. Now that machine's got to be a bit more robust. It's not going to be the cheap machine. It's not going to be the one with no redundancies. This is going to be the one with 10 gigabit NICs. This is going to be the one with, powerful hard drives, maybe a lot more processing and compute and memory. So those types of sizes might be a concern. So thinking about that from the beginning, you kind of have to work backwards. Like, how much is it going to cost me per user in infrastructure, and how much can I afford? Cloud in a lot of these situations we see is just not the answer. It's way too expensive. So they'll use it for things just like bursting barely above what they have capacity wise. You know, maybe there's an event, and cloud does make sense temporarily. So network quality, we want to talk about the most important thing in gaming is latency. Obviously, you know, you've got a great game, you have huge player base and lots of engagement, and everybody loves it. But if that network quality is not there, it just destroys the game. So when you're looking at persistence, you really have to be picky about where you're putting these things. Lots of testing on the network is exceptionally important, and you won't get to do that until you have that server runtime and you start really digging into some of those scale tests. So again, early is key. Patching for an MMO, I think we're all really familiar with the, you know, downtime. Somebody shuts the game off at midnight, everybody runs away, and you know, what are you going to do? You're going to go fall in love with another game, right? Until patch time is over. So keeping in mind all of these different types of sessions, maybe patching should allow you to have multiple game versions running at the same time. Maybe bleeding in patches over time where you can keep players engaged is something that you probably want to think about. Restart is not trivial. You know, when I think about what happens if I restart a backend, you know, a matchmaker, a database server, a game server, etc., you know, there's a lot of things that I've seen. One surprising thing that I glean is that in evaluating some game server runtimes, we've seen ones that dial home right after they restart. They check in. Not a bad thing, right? Well, what if that restart in between sessions is every 2 minutes and it dials home? What if you have 500,000 of them doing this? What if they crash and then reboot every single time they crash? You can imagine the kind of problems you're going to run into. So how you restart each and every one of those services is pretty critical when you think about it from a beginning of design phase. You know, runtimes that run for a long time. I've seen Unity and Unreal Game Server binaries that will actually, over time, just become destabilized. You know, maybe the usages are out of control. Maybe assets loaded in RAM just, you know, they're running out of memory or they're just not responsive. There's a lot of things I've seen as far as instability for long running processes. So if you're looking at how to restart those in those MMO instances, for example, they take a long time to boot up. Sometimes they might not be ready for players while they're still loading in maps and assets and terrain bits, you know. So when you're looking at a long runtime, you have a lot of problems to solve that sometimes aren't related to gameplay. They're just related to what happens when I turn these things on and off. Cloud cost, every time I reboot it, right? I'm going to consume CPU, RAM, egress. So there's a lot of compute concerns there. So maybe if I'm restarting these things continually, that actually represents more load than if I have that session running indefinitely and I just clean up in between. Maybe those spikes into CPU are higher in this situation. And then, of course, patching, right? I want to be able to patch my game server. I can't do it live, so I'm going to have to restart that thing to apply it. How do I do that across my fleet? So the way you design your game loop, right, considering all of those things can limit you. So just keep that in mind. You're going to have to restart these things, and you should always have the ability to have some kind of resilience when you do so. So when we talk about session duration for session-based games, we're talking, you know, no restarts and then restarts in between sessions. So for this one, we're talking about what happens with that shorter game session when we're restarting in between individual matches, right? There's a lot of advantages there. You don't have to worry about stabilizing a runtime if it becomes unstable for a long period because you're just going to keep restarting it. So maybe that carves a huge amount of work off your development plate. It sounds dirty, but you know, when we're in cost-saving maneuver, sometimes extra hours in a development cycle could be better spent making better textures, fit and finish of the game, maybe gameplay itself could be improved rather than worrying on those things. So, you know, there's a savings, a cost, and maybe you can translate that to another area of your game development. You know, rolling out patches, really, really simple, right? If those games are restarting very quickly, you could literally just point them to another version of the game after that game has ended. You restart that old server, reboots on the new runtime, and then you're good, right? So you can bleed in patches pretty quickly. The ease of scaling down. When we're talking about restarting in between sessions, that means we can turn them off. They don't have to sit there in idle state waiting for players. So what this allows us to do is when we're talking about scaling down out of cloud, maybe you have a hosting provider that has the ability to defragment their fleet when they're scaling up into cloud, and they actually start all those sessions on the same cloud instance, and then they bleed away at the same time so we can turn that thing off and save money. Restart in between sessions makes it easier. Unity and Unreal will, create new log files in between sessions. So now you're not scraping this giant log file that has a whole bunch of delineations between game sessions. Now you have a separate file per session. So this makes debugging a lot quicker, makes it easier. It also means that if you don't have sessions that you care about those logs, you can throw them away faster. So definitely lean and mean. And when we talk about the disadvantages, there's a couple things here that may be sticking points for you. Shorter sessions, again, like we talked about, they represent huge load on the back end. They're going to be noisy little buggers. They're going to make API calls more rapidly. They're going to do it in between every single game. Maybe you have to have a more robust API system on your back end to handle that. Maybe you need resiliency regionally to handle that. So sometimes this may not be the answer. Sometimes the way that your game works better, you might not want to have restarts in between sessions. Cloud compute costs for restarts, we talked about that, so we'll kind of move forward. Race conditions, this is something we've actually seen before. Game server starts up, it's been allocated, and it's not quite ready for players yet. So unless you've got an orchestration technology or provider that provides something like server readiness to let people know, hey, that runtime is actually ready for players. We did finish loading the map. You can run into situations where you're piling players into a game session before it's actually ready to take players. So that's kind of awkward. It'll cause a whole bunch of noise on the debugging end, and it may not be anything wrong with the game. It's just something that's simple, hard to identify. The memory and CPU spikes on startup, those are real. Maybe you think about how to kind of soften the blow there if you're going to go with this model, just to kind of eliminate the situation where if we do start all those game server sessions on that one cloud machine, it doesn't max out the CPU and memory for just that first minute or two on load. So maybe we have to spread those across multiple machines. So again, important to find a provider who can do those types of things. For matchmaking, when we talk about complexities, I mean, session-based games have a lot more maps and modes, right? There's definitely skill-based matchmaking we hear about, drop in, drop out. All of these things are very difficult to program around. They take a long time. So you want to find a matchmaker that marries well with your infrastructure that can probably soften some of those complexities for session-based games at restart. You definitely want to focus on that first, right? Machine performance, that can be hidden. I'll give you an example. I've got a bare metal machine. Somebody didn't turn turbo on that thing, and I'm not getting all of the gigahertz out of that box that I should, but I don't know about it, right? Because the sessions are so short that nobody complains. It's just kind of like, well, that game was kind of sucky. I've had some frame hitching. I didn't really get the experience I wanted out of it, but they're not going to tell you that. So sometimes you need a telemetry or something that does some kind of debugging to let you know where are those machines out there that just aren't quite up to par. Like they're passing when it comes to playing sessions, but they're not quite up to par. So these types of things can hide a lot of those.
Hey, Aaron, just before you go on there's a couple of people I think when you're moving away from your mic, just struggling to hear. So I don't want anyone to miss a nugget of information.
No worries. Thank you for that.
Yes.
So when we get back to sessions that we'll call them kind of persistent, but they're not really, right? This is still a session-based game, but these are the ones where we're cleaning up in between those game sessions and we're letting that game server continue to run. So in this one, sometimes this works better. They're always up and running. Those servers themselves, you can have a shorter game loop because you don't have to consider that restart time. You also have less load on your backend, right? If they call home when they start up, they're not going to be pounding you with API calls. And maybe they're more efficient. We can start to see some of the outliers of those machines out there that aren't as performant. We can carve those out of the fleet, or we can address them individually. Some people will say the disadvantages to this are that they're more difficult to design, right? They could become unstable over time, and now you have to debug how to solve a problem where you have a memory leak that rears its head over hours. Session cleanup, you're going to have to program for that. So it could be something simple. Maybe you don't have persistent or map type data that gets loaded in async on startup, and so you don't have much to clean up. Maybe it's just as simple as rotating a log file but you'll have to do those things programmatically. Idle state design is necessary here. So you need to have a game server that you can start up and it's waiting for players and it just kind of sits there patiently. You're also going to need infrastructure providers out there to maybe have the ability to turn that sucker off if it's, not had players in X amount of minutes, just to save on cost. Matchmaker aware, you have to have something that's going to be able to check into that matchmaker and let it know, hey, I'm actually available and ready for another session, even though I might have been allocated and I'm online. How does that matchmaker know that it is ready for a session? So you're going to have to program some of that logic in there as well. A/B patching is definitely a challenge, right? You're going to have separate game servers running maybe multiple versions, and you're going to have to slowly bleed those players over. And you'll probably have to shut those instances down to patch them. So, that's a different way of patching your game, and it might take a lot longer just because that game server is always running. When we talk about restart structure for session-based games, we're going to look at some real data here. This is actually a pretty decent sized game. I'm not going to really tell you what it is. We're going to anonymize this, unfortunately. But in this situation, I kind of built up and alluded to some of these problems, right? In this situation, the customer had a game server that on every startup, it would call home. It would check in with the back end. They had kind of a watcher process, if you would, to manage and maintain the fleet, which is great, right? If you don't have a hosting provider or scaling infrastructure that can do that, you're going to have to solve that problem. But the problem was it happened on every single startup. So what would happen, as you can see here, is over these days, right, these different versions that you can see indicated by different colors, you can see these huge valleys. And that's their entire infrastructure, all their concurrent players being kicked out of it when the backend had to be restarted. And this was simply because they basically DOSed themselves. When we're talking, dozens or maybe hundreds of players, they never saw any of the load there that would take out their backend. But when you have, like in this situation, over 100,000 players, and then they get disconnected and they're all smashing that matchmaking button over and over and over, you can imagine what kind of storm that would look like. And this is real. So testing earlier is definitely going to help you identify these kinds of problems and maybe missteps. But just keep that in mind, right? Is your backend able to be hit that hard at scale? You want to turn away those players when you reach a certain number of CCU. Now we're going to look at what it looked like post-patch. Now this is better, right? We've got definitely some restarts here. You can see they still had to turn down their infrastructure. And then over here, we started to see, there's still some issues. This is all during launch, mind you. So, that back end was a little hardened. They spun up more resources, so they had to increase their cost. Their CTO might have asked, well, what's the impact? What's the ROI look like? But at this point, everybody's just trying to put out fires. So I don't have time to ask those questions. They're just trying to save face and keep all the players happy. We get back to this last patch here, and this is what it should look like. Without this little pit here, we should see this nice smooth curve that just continues to go up day over day, region over region. And that's where you want to get to on that launch. You want it boring, right? You want the ability to just not worry about downtime and continue to patch in between them. Server tessellation is huge. This is probably the most important cost maneuver that you can consider. Does your provider understand that one map or mode may consume more resources than the other? Maybe you have a lobby and it's tiny. It doesn't use a lot of resources. But in the confines of this bare metal or cloud machine, are you optimizing server packing? Are you actually taking into account what the footprints resource-wise of each of these runtimes looks like, so that at scale, you're saving money rather than wasting it? Right? It would be horrible to have a cloud instance that, for instance, maybe costs you $800 a month running 24/7, and for 30% of the time, it's got 2 game servers running on it, and it could fit 40. That's a travesty. So how do you defragment that? How do you keep that from happening? So, maybe you need separate fleets for every one of these. Maybe you have a provider that can kind of fit them together and fence them off from one another. How many sessions per machine and what's the machine cost? Keeping track of those costs is pretty critical to running games as a service. And if you don't understand the impact there, you could end up upside down post-launch and never have planned for that. So tessellation up front, lots of testing, making sure that you make these decisions, finding a good provider that can help you with this. They're all solutions to this problem. You know, stability over time is also an issue. Are there too many players on a machine? Sometimes during that development cycle, we'll see that a game server becomes unstable after X more players are added to it. Or maybe there's a really noisy lobby that's got a whole bunch of physics in it. Maybe your net code is really noisy when there's a lot of latency that it has to compensate for, and it's eating up CPU. So all of those things you want to kind of consider, right? How do I keep these boxes stable? How do I keep their usage profiles as small as they could possibly be, but not change, you know? And packing those into every single one of those game machines at scale is what you need to focus on. The end goal is defragmented always. And we talk about backends. I'm not going to talk about what service providers you should use. I'm not going to talk about payment processing or any of that stuff, right? There is a lot of puzzle pieces here that you can use to build a game's backend. What we're going to talk about is how that actually influences your game at scale, and some of the things that people have run into while we're actually building a game, and their backend starts to kind of limit them. So this is my favorite slide, not because of the nuclear test in the background, but it's really just chaos resilience. You know, I come from the hosting world, and the hosting world was we have redundancies for everything from network, for hard drives, CPU. I mean, you imagine it, a chaotic situation, and we have, you know, proofed against it. That can be extraordinarily expensive. However, you still need to test that way. You still need to make sure if everybody crashes out of your game and you had to reboot your backend, and as we saw in that previous slide, how does people come back to that? You know, how does everybody respond, and what does that response look like to your backend? Can it handle it? So you're not going to be able to do this unless you have situational testing in mind. You know, let's start testing what happens if the matchmaker dies. Let's test what happens if people come back because they're being disconnected and they're pounding the matchmaker and creating a ton of match tickets. Those types of things can only be tested for if you got a provider that can spin these things up and down really quickly and can help you simulate some of those scenarios. So frequent testing before launch is definitely a good thing. You know, patching. You are going to be patching during launch. And I can't really stress this enough. There's so many programmers out there. There's so many game development studios out there that really just think, hey man, we've got this perfectly solidified. It's going to be great. We don't have to do anything to this runtime. We're stable. You're going to run into a problem. You're going to have to patch. So build your infrastructure with the ability to patch during production, during launch, during the worst possible time. Because when you've done that, then making quick changes is possible, right? Impacting players can be mitigated because you build this into the design of your game early on. So let's take a look at what this looks like. If you're running a console game or a game that's on multiple platforms, you're going to see something like this. And I recommend that you consider running multiple versions of your game simultaneously. You're going to have to probably do this. If you're passing cert through Xbox or PlayStation, that's expensive. It's hard to do, and it's going to limit you. Now, going through a PC launch is a lot easier. So you could probably have a later version of your game in PC live than you would be able to in Xbox and PS5, for example. So you want to make sure that your infrastructure can handle having multiple versions. Now over here in dev, right, we take a look at that. This is another thing, right? You want to have a sandbox with all of these different versions. You want the ability to update your game. And so if you have already built in the possibility for multiple versions to run simultaneously, that means when you patch, you're not disrupting players. There's no downtime. There's no sending players away for an hour or two while you patch the whole infrastructure. This is not easy to do, so I'm not going to tell you that it is, but the added advantage of being this agile means that, you know, maybe the launch didn't go so good on Xbox or PS5, but because you were able to continue to put content on PC and patch more, you got more player engagement out of that. So your player mass is shifted over to PC, and maybe you can sunset those other ones if necessary. Otherwise, what if you've got patches that need to be rolled out because of stability issue on PC, right? But it doesn't affect Xbox or PS5. If you're running off of one version, you're hamstrung over here and you're impacting those users, and you can't really speed up certification. So it's a thing to keep in mind. When we talk about scale testing, find a provider that is going to help you with this. Find a provider that is focused on scale testing and not just scaling up instances and throwing compute at it. Anybody can do that. Those big cloud providers out there love to see the bill go up. So they make it incredibly easy to ask for more. What they don't make it easy to do is what we alluded to before, and that's this server tessellation, right? This defragmentation. So in this model, this is kind of an optimal scenario, right? We've got a whole bunch of game server instances. All the bare metal is full. We're only using cloud because the bare metal is full. So this allows us to kind of scale up on demand. And that's kind of critical to a launch, right? You're not turning away players even when all that bare metal is full. You can also discover issues on scale up if you're doing lots of testing. Maybe some of these game servers aren't stable in cloud. Maybe they don't like cloud, and you don't find that out until you start testing it. Maybe the cloud instance you use is just not a good one, and maybe your provider needs to help you change that. But finding that out early is definitely a good thing. Scaling down. Well, scaling down is something that you have to consider because it's the most important thing you can do in scaling. This is where your cost savings is, right? If in this bare metal example here, where I have, a slot that's not being used, if that was a cloud machine and there's bare metal that's got slots in it, the question you might ask is, well, why am I not using this infrastructure that's cheaper? I can't turn off that cloud machine because it's got one little game hanging around there. And then maybe your matchmaker starts another one little game on a completely different cloud instance. So scaling down is not possible. So now you're wasting money. At scale, that could represent lots and lots and lots of money. We've seen game studios that had those issues and weren't able to scale down effectively. And so while they're trying to spin people down out of cloud, they're stuck waiting with instances that are just running maybe a game or two. The other thing to keep in mind is that when you're actually looking at scale testing, you want to make sure you leave enough time to fix any issues that you might run into. So whether you're adding bots to a runtime and letting it run a full game loop, or just simulating matchmaker load to spin up servers, you definitely want to do this with enough runway at the end of that, should you run into a catastrophic issue that's going to take you months to patch. So here's a long version of what it looks like when scale testing has gone well. And what I mean by well is this huge pitfall here, right? We ran into a problem. Now, obviously, this is a situation where it's not necessarily launched. This is a simulation. So we run into a scaling problem that resulted in a backend disaster. And this was discovered before launch. And you can see the simulated load here is many thousands of CCU. And this was done within enough time to patch the game to avoid this happening at launch. So when we talk about scale testing to those numbers, there's a cost associated with it in infrastructure, of course. But the bigger cost is, what if this looked like that last launch we looked at, right? And it just continued to happen every few hours. Are your players going to put up with that? No matter how good the game is, if they can't finish a session, are they going to put up with that? They're definitely not going to be buying DLCs, right? They're not going to be spending a lot of money if it's that unstable. So this is critical, and this is what it looks like when you're scale testing. There we go. There's the bad, right? And let's talk about the specifics of this. Again, we're not talking titles, but the impact here, these core issues were not discovered early enough. So it's not something that any studio should discredit themselves, like think of themselves as, oh, this was a horrible mistake, we really messed up. This happens all the time, but the cause was just simply not enough testing. They would have found this out, and if it would have been done earlier, they could have patched this before it ever impacted a launch. So you're going to run into weirdness like this because every single game that I've ever touched, and that's many hundreds, is different. It's not the same. Players were kicked out and the servers are being continually restarted. And that's because those game servers were failing to respond to something called query on startup. So when they called home, they didn't. And so their runtime said, if I can't reach home, I must be broken. I'm going to restart and I'm going to dial home again. This is where the DOS started. So maybe just a simple step in game logic and game mechanics probably would have eliminated that. That backend went down multiple times during launch. There were other problems discovered because of it. And that was simply because of servers being rebooted and calling home DOS the infrastructure. That's not a normal situation you should have to defend against. So now we're having to patch for abnormal situations that don't represent, what the future of the game is going to look like. So you might have had to scale that back end many, many more times than it needed to be. So you've inflated your cost. So again, all of this avoided by frequent testing with enough time to make those patches and fix those things. And finally, I mean, perfection is possible. And this is a great example. This is a real game, and this is during launch. And just like I told you, you will be patching during launch. And that's exactly what's happening here. So in blue, we've got this one version we've launched with, and you can see just over hours, right? We're actually pushing up another version of the game. And if you were to draw a nice little smooth line here, you'd notice that we didn't really lose any CCU, right? They were being exchanged out. Their matchmaker was being pushed to a new version of the game. And for this short time, there's multiple versions of the game running at the same time. You know, maybe this green one is a different version on Xbox, right? And we're patching it here. Maybe there's one that can't be patched. And so it's going to continue at the same version while all of these continue to run on their independent versions. So this is possible with a lot of testing and a lot of planning and working with a provider that has the tools to help you with these things. You can achieve this and not run into some of the pitfalls that we've gone over. With that, I'm going to hand it back over for questions and answers, and let's see if we can help you guys out with some of the questions you have lingering. Thank you.
Thanks, Aaron. That was awesome. I know we could have spent the next couple of hours going deeper on those topics as well with the level of knowledge. And the questions coming in certainly seem like people are enjoying that as well. So thank you. Keep those questions coming in. We've only had a ton already. As I said at the start, we'll be sending the recording to everyone by email in the next few days, along with details of the next webinar. If you've asked a question and we don't get round to answering it, we will answer all the questions that have been submitted that we don't answer live. We'll create a document and we'll post that on the multiplayer forums on Unity. So just want to let you know, if you've asked a question, it will get answered, even if we don't get around to it today. We'll give Aaron's voice a break. I'll hand over to Dan Richards, one of our senior software engineers on a multiplayer team, who will moderate the Q&A and go over the ones that we've got coming in. So what have we got, Dan?
Hey folks. So first one up we have is, can we use WebSockets for creating a real-time player movement game? Aaron, do you have any experience with folks finding successful WebSockets for that kind of use case?
Yeah, we've actually seen people use WebSockets for netcode on some games. And it really just depends, right? If you're high tick rate, high refresh rate, and you need netcode that has to accommodate for that, then WebSockets might not be the best choice. But there's a multitude of netcodes out there. We've got a few that we're playing with. Don't let that limit your choices. There's a way to use different netcodes, and I invite you to test them. How much CPU does one netcode use versus the other? Overkill is possible. So if you don't have a high refresh rate on your game, then maybe WebSockets is going to work.
Very nice. Yeah, absolutely agree. Yeah, testing and working out your netcode budget, absolutely crucial in that use case. Okay, so next question we had was, could you provide a diagram or guidelines about what is the best practice to create a multiplayer game in the cloud? So I guess my take on this one would be thinking, what do we mean exactly by a multiplayer game for a start, and also what do we mean by the cloud ultimately? Is it the cloud we're looking for? Is it reliable capacity? Is it cheap capacity? There's a number of aspects we could really think about there, Aaron, right?
Yeah, definitely. There's lots of diagrams. Obviously we can be engaged. We have a sales team. We have engineers that can kind of look at your particular situation and probably give you some guidance. We've seen lots of game launches, so always happy to engage there. Check out the website if you don't see the collateral there. Engage one of us. We'll be happy to share what we know.
Thank you. Very good. Okay, this is an interesting question. So could we explain a little bit more about the difference between a persistent and a long-running session? I think this is interesting in particular because there's a non-trivial overlap, I think, between those in a lot of cases. Long-running sessions, maybe we're dealing with some persistent worlds type game or an MMO or something like that, and they are likely, I think, to be in a world where you've got a long-running server that also has persistence needs as well. So when we say persistence, we mean things like reliable databases or flat file storage or some kind of world state that needs to persist longer than the lifetime of the server itself. as somebody's called out in the chat, Minecraft in general. So Minecraft realms, things like that. That's what we mean by a persistent session. Whereas, a long running session is a server that's not necessarily going to be session based. So it's not a game of Counter-Strike. It's a long running overworld server or something like that. Aaron, anything to build on that one?
I think you nailed it. MMOs are the ones famous for being that persistent world server type scenario, where that game server stays online all the time. And as players kind of pop in and pop out, you're asyncing data in, maybe you're streaming what's happened to that world as they walk through it. So when we talk about persistent and not session based, that's kind of what we're referring to. So I think you nailed it.
Nice. And I think the next question leads on to that a little as well, is how would you approach a game like Escape from Tarkov? So type of session length, persistence or not, cloud or not. And I think much of what you were talking about there is going to feed into that, isn't it? It's the need for persistence, the length of those matches, ultimately the amount of game state that we're dealing with, synchronizing to the players there, the authority model, and ultimately a game that's doing a lot of game state synchronization, maybe with a high netcode budget. You're going to want to consider your network egress costs, things like that. I've not played Tarkov personally, so I don't know much about the game mode. So Aaron, if you've played it, maybe you can speak more to it.
Yeah, I mean, it's a different world of scene-based versus streaming engines when you're talking about persistent worlds like that, where you're constantly changing the state of it. So maybe you have a streaming engine that can handle that. Maybe you have to build a data layer where you can constantly, like, you always think of this hexagonal sphere of influence, right? As you move through this world, and as you walk up to something that some other player changed, you have to async that data in. So when we talk about those types of design considerations, different engines have different advantage over them. But maybe you can solve that with a simple data service. So there's a lot of different ways to talk about persistence. Maybe certain modes of that game have a session. And so you might have a fleet where you have two different types of infrastructure architecture because of that. Big giant server for the world server situation and small ones for those little breakout sessions or mini games, if you will, or lobbies.
Excellent. Nice. Okay. Do we have any tips on performing, analyzing, or setting up server stress tests? So to your earlier point on testing.
Yeah. We have a case study out there for Respawn, and what they did with the ability to populate their servers with bots that could simulate a game loop was pretty important. Having the ability to simulate players and everything that they could and would do lets you actually simulate what a launch looks like. And the closer you can get to that, the better you're going to get metrics for cost comparison, understanding what your player budget is, what your ROI looks like. So you'll impress your publisher when you can show them that you're being cost conscious and you can simulate what that cost looks like at scale. There's definitely a lot more that I could pile in there, but it just depends on what you're trying to accomplish and what kind of game you're running. I would invite you to talk with people like us. We could definitely analyze your specific runtime and help you evaluate what decisions that you should be considering when you're going through this. But at minimum, I would just say simulate as much of a game loop as possible without having to have real players in it.
Excellent. Yeah, fully agree with that. Okay, next on the list we have, would it be advisable to launch on one platform and then add other platforms later? I feel like we've seen a mix of multiple strategies here. Do you think there's any patterns or anti-patterns to this one, or is it really on a sort of game-by-game basis?
Yeah, no, I see whether it's AAA, indie, persistent, non-persistent, tiny games, huge games. I see this pattern. It works really well. All right, we're going to launch on the easiest platform first, and then we're going to layer in the other ones after we get the game in a state where it's had live players and we've maybe run into some of those things and banged our head on little things and patched them. So I see a kind of a PC and then a console approach. If it's not a console-based game, some people will just stay on PC. If it's mobile, it's kind of different, right? You're going to want to push out on both mobile platforms as soon as you can, because you might lose the marketing cadence, if you will, if you wait for one platform versus the other. We also see impacts when you go free to play. So in some situations, you kind of get a huge reboot and more people piling in when you're going free to play, and then you find out you have to patch more. So I rarely see game launches where we're going to push it out across all consoles at the same time. That's an ambitious move. I have seen it work, but it's very, very challenging. So maybe the PC first approach works better for you. Maybe consoles aren't the way. So there's a lot to consider there.
Yeah, agreed. Fully agreed. Okay, a question about NGO. Does NGO support crossplay between Android and PC?
I'm not going to lie to you and say I'm a netcode expert. I definitely don't. We have a team for that, and we should definitely engage them. But I don't think there are any barriers to entry as far as crossplay with the different netcodes out there, especially NGO. When you go through certification, there's going to be some questions asked. You're definitely going to have to pass, that review. So I want to definitely connect you with our netcode team to definitely field that one. That's definitely not my wheelhouse.
Yeah, likewise agree with that. Yeah, we've got a great team behind the Netcode product. So yeah, we'll definitely be able to put you in touch with them and encourage you to check out the Netcode docs in the meantime. Okay, next question is, what exactly do we mean by a game server calling home? I think my take on that would be a game server when it starts up, or at some point during its life cycle, making a request to either register itself with a backend service or update its state in a backend service. We see matchmakers that are stateful. So when a game server comes up, it wants to register itself as existing with a matchmaker, and then the matchmaker could use that to drive players towards it. I'm guessing that was your intention by that comment, Aaron.
Yeah, there's also validation. Am I a real game server? Did I authenticate? Am I a real target that you can put matches on, or am I a bad actor? So there's a security piece to it as well. But like you said, I think there's a lot of different ways that they dial home, but most of the time it's just observability.
Yeah, great call out. Okay, we have a couple questions on testing. So do we have any recommendations on testing tools? I'm assuming this is in regards to sort of load testing the game servers themselves, or maybe creating bot fleets or something to that effect.
Yeah, from the game design itself, there's a different team out there that could probably help you suggesting bot design and how to do that. That's where I'm operating more on the server side of things. So on the server side of things, we have a matchmaker that will allow you to simulate matchmaking requests at volume for a multitude of different regions, a multitude of different rates. So that's definitely key. Having a way to simulate those matchmaking requests and kind of, shotgun blast approach to your backend infrastructure is pretty critical. But that's a real neat tool to have. And it solves a lot of problems because when it comes down to it, you're simulating what the real world is going to do when they're asking your infrastructure to respond to all those requests. So you can do a lot of neat things if you have a matchmaker that allows you to simulate that.
Excellent. Okay, we've got about 5 minutes left, so I think we can get through one or two more questions. Serverless, is that a good idea for backend and matchmaking? That's a really interesting question. I think serverless can be a workable option because ultimately you're going to get a pretty good efficiency there if your workload is bursty. So serverless is pretty good for scale to zero scenarios where you can run the workloads while you need them and scale them back down to a zero capacity, which is pretty cost efficient when they're unneeded. You would need to consider things like the initial ramp up time for the first few runs of those functions, because as those sort of Lambda cloud function situations spin up, the first runs can take a little bit longer than later runs. Cost would also be a consideration there. If you're getting high volumes and you're being charged per execution of that function, that might also be a cost factor to consider. Any thoughts on serverless from your side?
I mean, resiliency. When we go serverless, those are generally proprietary technologies from one single cloud provider. I would say if Google goes down or Amazon goes down or Azure or any of those other cloud providers go down, what happens to your backend? Serverless has advantages, but if you're going to do it, make sure that you build some resiliency in there because you're going to experience a cloud outage at some point. It's the reason that we use multiple clouds.
Yeah, absolutely agree with that. Okay, what are some successful strategies you've seen when mitigating the problems of servers phoning home when they start up? Presumably they have to notify the backend that they're available somehow. So I'm thinking this is probably going to be around retry patterns and that sort of thing.
Yeah, I think query is important here. There are several query protocols. Amazon has A2S, we have an SQP, and it's really nothing more than an open UDP port that can be secured that your backend and ours can interrogate and learn things like map mode, state, and number of players. And so if you have something like that, then there is really not a dial home feature needed. You literally have the ability for your backend to query the servers And then it can do that in an expected and at scale fashion rather than having to respond to a whole bunch of incoming phone calls. And so that's one way to eliminate that problem, right? Don't make your back end have to do all the work. Or sorry, don't make your servers have to pitch work to the back end. Make the back end be the outbound caller.
Yeah, good answer. Very nice. Do platforms like Photon deal with all this stuff for you? That's interesting question. I'm not sure what we mean by all this stuff in this case, but Photon is definitely a good platform for a number of different use cases. It's pretty flexible in terms of working with a number of different multiplayer models. You can do peer-to-peer there, you can do shared authority, you can do server authority. So I think from a netcode perspective, it's pretty good. It does a lot of interesting stuff. They don't offer a dedicated server hosting solution as part of the Photon package, but you can run Photon games on Unity Game Server hosting. We have a Photon sample game called Fusion Battle Royale, which is built in Photon, so it definitely is a good option to consider. Any thoughts of your experience with Photon, Aaron?
Actually, I think you covered it brilliantly.
All right, lovely jobs. Okay, Matt, are we done questions-wise or time-wise?
I think time-wise, yeah, that feels like a natural pause. So as I said, if you've submitted a question, we will answer it, and then we will post that as a single doc on the Unity multiplayer forum. So just want to take this opportunity to say thank you everyone for joining. Thank you everyone for participating. Hopefully you agree it makes it much more interesting and interactive session. Thank you, Aaron, for that. That was really useful. And Dan, that was just a mind of knowledge at the end. Yeah, loved it and seeing the questions and engagement. As I said, keep your eyes peeled. We'll send out the recording and details of the next webinar in the series as well. And we will leave it there. Have a great rest of your day or evening, wherever you are in the world.